I'm excited to introduce the Multi-Agent Forecasting System, a generative AI and explainable AI-driven solution developed by Venture Technologies in collaboration with our AWS Advanced Tier partnership. This platform transforms the way businesses forecast demand across SKUs, regions, and channels. Traditional forecasting struggles with complex data patterns, seasonal fluctuations, and hyperlocal customer behavior, making analysis slow, inconsistent, and hard to explain. Our solution uses collaborating AI agents for data prep, forecasting, trend analysis, anomaly detection, and deviation insights. It delivers accurate, transparent forecasts and includes a GenAI chatbot for quick, business-friendly answers. Built entirely on AWS, the solution leverages scalable, secure, and reliable cloud components, ensuring fast processing, enterprise-grade availability, and seamless integration with existing systems. The architecture automatically scales with data volume and workload, making it ideal for retailers handling millions of SKUs or complex, distributed supply chains. With that, let's move ahead and see the demo in action. Multi-Agent AI Forecasting System, where forecasting becomes transparent, intelligent, and truly business-aware. Today, I'll show you how multiple AI agents work together to deliver clearer insights, smarter predictions, and real-world adaptability. Here we begin with the filters, where you choose the SKU, channel, distributor, and city for the analysis. This panel gives a quick overview of the model's performance metrics compared against traditional forecasting methods. This section is where you can upload data or initiate training for the selected configuration. Once everything is prepared, this button triggers the training process. Here we begin with the regressor agent, which identifies the key drivers and patterns hidden inside the historical data. This section is powered by the diagnosis agent, focusing on uncovering why forecasts deviate from actuals. And here, the adjustment agent steps in, applying intelligent corrections to refine and improve the forecast. And finally, the forecast assistant lets you test real-world scenarios and instantly see their impact on forecasts. We begin the demo by selecting SKU, channel, distributor, and city. Based on these filters, the system automatically prepares and cleans dataset, handling outliers, missing values, and formatting time series for deep AR. Data is then split into 33 months for training, 2 months for validation, and 1 month for testing. With a single click on Start Training, the deep AR model begins learning underlying patterns. Now let's explore Trend Analyzer, our first agent, the regressor agent. This agent identifies key drivers that shape demand. For every driver, whether it's promotions, festivals, or seasonal patterns, it highlights not just what influences forecast but also why. Each driver is explained with a corresponding plot, giving business teams complete clarity. Agent then walks us through seasonality and long-term trends. You'll notice strong demand peaks around major festivals in August and an overall stable upward trend over time. Agent also highlights anomalies, unexpected spikes or dips in sales. For example, spike in April 2023 is linked to Good Friday and Eid ul-Fitr. Similarly, spike in September 2025 is associated with Navratri and Ganesh Chaturthi. These anomalies can be visually cross-checked in the overall trend plot, ensuring full transparency behind model interpretation. Second agent takes baseline validation forecasts and compares them with actuals. For example, in October 2025, model forecasted 142 units, but actual sales were 93 units, a deviation of 35.4%. This is classified as overforecasting. Key driver here was festivals, which inflated expected demand and caused forecasts to overshoot actuals. In November 2025, forecast was 146 units, but actual sales reached 204 units, a deviation of 14.7%. This is underforecasting. Reason: a special offer period created a temporary demand lift that wasn't fully captured in historical pattern. Third agent uses this diagnosis to intelligently adjust forecast for final test month. it takes original forecast and modifies it, upward or downward, based on patterns it observed. For December 2025, original forecast was 161 units, and adjustment agent increased it to 171 units. Why? Because recent underforecasting trends and strong festival signals indicated increased demand. Fourth agent acts as bridge between planners and forecasting system. When a planner enters a real-world scenario, something that never happened in past, this agent adjusts forecast instantly. For example, if temperatures suddenly rise very high, system predicts a 5% increase in demand. Final forecast becomes 183 units. Reason? Higher temperatures may lead to increased demand for body spray 500 milliliters. Confidence level 75%. Another example, doctors recently suggested using roll-on sprays to reduce risk of heart disease. Model indicated that demand for spray would reduce by 8%, giving a final forecast of 160 units. System explained that shift toward roll-ons could reduce spray demand. Together, these four agents transform forecasting from a static number into a living, adaptable decision support system.